Assalamualaikum and hi everyone. We are from Group 1. We want to present about differentiation. Uh, my lecturer's name, Madam Intan Faradina binti Zain. Course DBM20023. Course code Engineering Mathematics. My name Muhammad Adib bin Muhammad Zaki. No matrix 01 DAD 22F1029.
The next one is, my name is Muhammad Fakhr Aiman bin Kamaruddin and my matrix number is 01DAD22F1037.
My name is Muhammad Firdaus bin Zaro. My matrix number is 01DAD22F1004.
My name is Muhammad Izril Mushrik bin Kazani. My matrix number is 01DAD22F1013. For introduction of differentiation, differentiation is a method of finding the derivative of a function. Differentiation is a process in math where we find the instantaneous rate of change in function based on one of its variables. The most common example is the rate change of displacement with respect to time called velocity. Differentiation allows us to find rates of change. For example, it allows us to find the rate of change of velocity with respect to time, which is acceleration. It also allows us to find the rate of change of x with respect to y, which on a graph of y against x is the gradient of the curve.
The next one is application of the differentiation in real life. Rate of change of a quantity. This is the general and most important application of derivative. For example, to check the rate of change of the value of a cube with respect to its decreasing size, we can use the derivative form as dy per dx. Based on the graph, as you can see, the red line is fx and the yellow line is a local maximum, and then the blue one is local minimum, and for the green is saddle point.
This is our question. We got question C and D. If you can see, the question C is y equal 5 x cube plus 2x square minus 7x minus 2. And the next question D, y equal negative 5x cube minus 2x square plus 7x plus 2.
Alright, for first question, question C. Use differentiation to find expression for dy over dx. Y equal 5x cube plus 2x square minus 7x minus 2. Dy over dx. We get y equal 5x cube plus 2x square minus 7x minus 2. And the answer dy over dx equal 15x square plus 4x minus 7. Question number 2. Find the coordinates of any stationary points on the curve at stationary point dy over dx equals 0. 15x square plus 4x minus 7 equals 0. And we separate it. X equals 0.56 and x equal negative 0.83. When x equals 0.56 and y equal negative 4.41, we get x equal negative 0.83 and y equal 2.33. Question 3. How many stationary points does the graph have? The answer is 2 from the previous question. For question number 4, determine x-intercept and y-intercept point. The x-intercept point is on xy with y equals 0. When y equals 0 and 5x cubed plus 2x squared negative minus 7x equal minus 2 equals 0. X equal 1.14, x equal negative 1.26, and x equal negative 0.2x. And when x equals 0, y equal 5 0 cube plus 2 0 cube.
Alright, let's go to the question number 5. The question is determine the nature of any stationary points we found in part 2 and justifying your answer. Alright, the answer we got is 30x plus 4. And then after we get the answer, fill when x equals 0.56, just fill the x into the d square y over dx square, and the answer is like this lah, right? And then when x equal negative 0.83, the answer is negative 20.9. This is the main point lah. Alright. Let's move to the next question. The last question, question number 6. Sketch the graph of the curve. If you can see this graph, when what we got the coordinate, and then we just put at the graph like this lah. Alright.
Question D. The graph of the curve with equation y equals negative 5s3 minus 2s squared plus 2s plus 2. 1. Use differentiation to find expression for dy dx. So y equals negative 5s3 minus 2s squared plus 2s plus 2. So differentiation dy dx equals negative 50s squared plus minus 4s plus 7. Question 2. Find the coordinate of any stationary point on the curve. So at stationary points, dy over dx equals 0. So negative 50s squared minus 4s plus 7 equals 0. So you can use calculator to find x1 and x2. So x1 equals 0.56 and x2 is negative 0.83. When x equals 0.56, y equals 4.41. When x equals when x equals negative 0.83, y equals negative 2.33. So the conclusion, the stationary point 0.56, 4.41 and negative 0.83, negative 2.33. Okay. Question 2. Question 3. How many stationary points does the graph have? So stationary point we get is 2. Okay. So question 4. Determine the x-intercept and y-intercept point. the s-intercept point is n x, y with y equals 0. When y equals 0, negative 5x3 minus 2x square plus 2x plus 2 equals 0. So s equals 1.14, x equals 1.26, and lastly x equals negative 0.28. So the conclusion, the s-intercept point the conclusion, the s-intercept point are 1.14, 0 and negative 1.26, 0, and lastly negative 0.28, 0. The y-intercept point is n as y with at 0. When at 0, y equals negative 5 multiply 0, 3 minus 2 multiply 0 square plus 7 multiply 0 plus 2 equals 2. So the y-intercept point is 0, 2.
For the question D5, determine the nature of any stationary points you found in part 2. Justify your answer. The nature of any stationary points d square y over dx square equals negative 30x minus 4 when x equals 0.56, d square y over dx square equals negative 30 multiply 0.56 minus 4 equals 0 equals negative 20.8 less than 0. The point 0.56 and 4.41 is maximum point when x equals negative 0.83, d square y over dx square equals negative 30 multiply negative 0.83 minus 4 equals 20.9 more than 0. The point negative 0.83 for x and negative 2.33 is minimum point. So for the question 6 is sketch the graph. Based on question 2, 4 and 5 we have got the answer, so we just put the point answer into the graph. For example, this is what I got when I put the point into the graph.
Summary. Differentiation is a method of finding the derivative of a function. Differentiation is a process in math where we find the instantaneous rate of change in function based on one of its variables. The most common example is the rate change of displacement with respect to time, called velocity. Differentiation is a process of determining the rate of change in a quantity with respect to another quantity. Integration is the process of bringing smaller component into a single unit that acts as one single component. Differentiation is used to find the slope of a function at a point. Thank you. Bye.